Hey there, I didn't see you there.
How are you doing, Roman?
I'm doing good. You want to know what we're doing for this project?
I would love to know what we're doing for this
So
project.
basically we're getting a robot and we're putting an arm on it with like a magnet. So we can fuel our rocket ships because we don't want to endanger human lives and accidentally spill all over themselves the rocket fuel. So robots will be more efficient. And we're going to be using a line follower and some ultrasonic sensors and a little GPS tracker so we know where the robot's going and fuel our rocket ships.
That's pretty nice. That's pretty nice.
Yeah.
I hate when fuel spills on me at the gas station.
Yeah, I know. It's one of the worst things.
That stuff's so annoying.
Yeah, it gets all over.
Well, thank you for informing us, Roman.
Yeah.
Austin, what you working on?
Hey Roman, I'm working on our drawing for what our robot's going to be doing on said Mars terrain. We are going to be having our robot use a line follower to follow a line that we place on the planet Mars to get fuel delivered to the rocket. Now, in case something were to fall or cover the line, we will have ultrasonic sensors on the front of the robot to detect that object. It will go around the object and try to find the line again. Once it finds the line, it'll follow the line to the rocket to fuel it up so that we can have our liftoff party. And what's great about this is when it finds the line, instead of going back down the line to the object, it'll be using its GPS to always go to like north or south based on where the line's supposed to take it.
Go.
So what preventative measures could we add to the robot to make sure it gets the fuel to the rocket ship?
Well, I was like looking, and I'd say we should probably make it like follow a line, because last time we made it like follow like a coordinate, but that did take a while, and it's like a lot more dangerous too, because it's not like a set path, you know.
So maybe a direct path that we outlined prior would be more helpful. Something we could use multiple times.
I think that would work. However, what if there was like an obstacle, say a crater? How do you deal with that?
Well, I'd say if there's like an obstacle, we can make the robot go around it, and then make it like, find the line again after it's around the obstacle.
Just to make sure, what is the objective of this system?
We are trying to move fuel to the rocket so we can supply the rocket.
Yes, that makes sense. Okay, moving on. Carson, do you have any remarks to add?
I think that it would definitely be good to make sure that if there are any obstacles, it can get around the line. I'm a bit worried that, like, if it tries to go around, would it, like, find another part of the line and maybe go the wrong direction?
That's definitely something we should consider. Another thing I feel like is what if it misidentifies something else as the line? Like, let's say it finds something that's like kind of whitish and it starts using that as the line. So that's
Okay, fair. How many lines do you know of on Earth? On Mars surface?
Yeah.
Not many, but like let's say there was a piece of something like a piece of like rubble or scrap that was happened to be
Well, I
white.
hope we're not leaving scrap everywhere on Mars.
Me too. But you never know what
Because
happens.
we are a safe and good company
But I know
with
it.
strong morals.
I know exactly who would ensure that. And we would have one person to ensure that that would never happen, right, Carson?
Yes, and as my job of the safety manager, I would make sure that our robot would be able to safely navigate to the object without any debris.
Splendid. We'll start development now.
This simulation demonstrates the robot's ability to overcome different obstacles that may be in its path, like along the line that it follows, and then it will navigate around those obstacles and try to find its way back to the path, ensuring that it keeps the proper gyro direction at the end of it so that it doesn't go like to the wrong line or the wrong direction.
Hey, it's me, Tyler, and we're running it back with the code. So first thing we have are necessary imports, and then we create all the objects for the motors and all the sensors we're going to use on the robot. Next thing we have are our constant variables. We have the color of the line, the distance that the robot needs to be for it to mark as complete, the detection distance, where the minimum distance which something is considered an imminent collision, and then we have our loop delay, which is the delay all the while loops will be using so that it's less intensive on the CPU and the robot. And then finally, we have our gyro origin offset, which is just the gyro starting rotation, basically. Next, we have our two, math-based functions. First we have clamp. It just basically ensures the value that we put in is between the two parameters right here. And then next we have sign, which basically returns the sign of the value we input into the function. Next we have detect line. This function just basically tells the robot where the line is if it detects it. First we get our line detections and determine if there is a line there. And then we run it through some logic and then return none if the line is not there. Next we have a get outer detects function. Basically all this is doing is the two outer line sensors, which we do not use in the initial function we just went over. We use this only on this function, which basically just gives us if the line is to the right or the left of the robot. And we use that as a last seen detection for the robot if it goes off of the line. Next up we have our get distance function. All this is doing is giving us the magnitude of the robot is from its ending position that we put into the function. We have detect end. All we're doing here is we're detecting if the robot's at the end of the line in its journey using GPS. Next up we have face target. What this one does, we get the coordinates that we need to face, and then the robot will rotate until its gyro tells it that it's facing that angle. We're using the absolute angle, the robot angle, and then we're calculating that and putting it into the orientation offset, which we will then use to determine if the robot is facing its target or not. Next up we have our detect going off course. Basically this function is doing one of our big things that we had is the robot was rotating too much and then it would detect the line behind it and then start going backwards. This function makes sure the robot cannot rotate more than 90 degrees, therefore it won't be able to actually detect the line behind it, eliminating that problem. Next up we have our stay on line function, right? So what this one's doing is it actually makes sure the robot stays on the line. So what we're doing is we're getting the line detection where the line is, and then we're going to do, if line detection is not 0, meaning it's not in the center, we're going to check if the line is actually there. If it's not, we're going to rotate to the last seen area. We're going to check if the robot is going off course, rotating too much. We're going to reverse it and make it go the other way. And finally, if the line is between the center sensor and the rightish out sensor, or vice versa, we're going to have it rotate in 90 degrees, right? Stationary. Else we're just going to make it do a slight turn while still moving forward. Then finally, we're going to set things up for the next iteration. If the line has been detected on either of the outer sensors, we're going to set that as the last side detected for the next cycle. And then finally, we're going to return our values. The next method we have up is our detect obstacle function. Basically, all this does is it's going to get the center distance of the ultrasonic sensor detected, and then it's going to see if it's less than the detection distance. And we're also going to make sure that it's not detecting the endpoint by calculating if the distance from the endpoint is less than the calculation distance. Next up we have is our avoidance procedure. Basically all this does is when an object has been detected, we got to get around it, right? So what we're going to do is we're going to face 90 degrees of the robot, and then we're going to go straight for 5 seconds. We're going to turn 90 degrees, go straight for 11 seconds, and then we're going to turn 90 degrees. Then finally, we're going to turn on both motors so the robot goes straight, and it's just going to keep moving till it detects that line again. And then we're going to turn the motors off. Next up, we have the main function that we will be using with our two inputs as the coordinates and then the max RPM. We're just going to make sure that the max RPM is not below 0 or equal to 0. Then we're going to calculate the max RPS. We're going to set up our dynamic variables we will be using. And then we're going to have the main while loop. This while loop is basically going to run until the robot makes it to the end, and it's going to make sure the robot stays on the line and avoids all the obstacles. For this to work, we're going to be using a variable to determine the robot's behavior, right? So basically, if there's an obstacle present, we're going to set the stop angle so that it knows where not to go, the max it can rotate. And then we're going to set the current behavior to avoid, avoiding the obstacle. If there is not an object present, we're going to check if the line has been detected, and if it has, we're going to set it to follow, so it can follow the line. Next, we're going to call that stay on line function as earlier. And then we're also going to, if the current behavior is avoid, we're going to do that avoidance procedure. Then finally, we're going to see if the robot has reached its destination. And then we're going to take some extra precautions to make sure the RPS, the left and right, doesn't exceed a certain amount. And then finally, we're going to apply those values to the motors themselves, and then sleep for that loop delay we were talking about. And then turn off the motors. And then finally, we have the main function that runs everything. Basically, all this is doing is we input the coordinates, the robot coordinates, we want the robot to go, the coordinates that it will be rotating to face at the very end, and then we're going to call that follow to target function we just talked about. We're going to wait a little bit, and then we're going to face target to make sure the robot's actually looking at the area that needs to drop off the payload.
What's one problem we had, James?
Well, one problem was initially we built a claw with a magnet inside it so it could pick things up, but the magnet wasn't properly activating and the claw didn't have enough force. So we moved to a kind of scooper system to move things out of the way. So you just run right into it, it picks it up into the mandibles, and then pushes it out.
So, Sebastian, what's one problem that we had, and how did we solve it?
While we were working on development, the robot sometimes would occasionally, while it was moving on the line, it would sometimes move off of the line. And this was a problem because it'd basically lose track of the line and it would not be able to navigate to its endpoint. However, we solved this by adding sensors to the sides of the robot core sensors so that if the robot strayed too far off the line, it would notice it and it would be able to turn stationarily to readjust itself so that it never stray off the line. Similar to how some self-driving cars have sensors to check where the curbs and the lines on the road are. Thank you.
All right, Carson, what's one problem we had?
So the robot would initially start facing in the direction of 0, and the gyro would read 0. But if the robot didn't start at the very beginning of the line, the gyro would still think it's facing the 0 direction, so it would start doing incorrect turns and it would lose the line. And we fixed this problem by basically giving us a way to tell the robot and the sensor where it's beginning so that it knows what to do from there.
All right, Tyler, what is one problem we had?
So basically, the problem that we had is that the robot was. I'm sorry, you're gonna have to.
All right, Tyler, what's one problem we had?
So one problem that we had is the robot was like turning too far, and then it would detect the line behind it, and then start moving backwards. How we solved that is that we made it so the robot cannot turn more than 90 degrees when it's like stationary turning, so that it'll never be able to pick up that line behind it.
So Roman, what did you learn?
Well, I learned that practicing a robot through simulation and coding is a very important part to know what you're doing. And when we're doing the real thing, we know that our robot is going to run smoothly. All right, Sebastian, what's one thing you learned?
Well, while in development, I learned how crucial it is to have full sensor coverage around whatever vehicle that we use to make sure that it can successfully navigate down any path it needs to go and get around obstacles without getting off track. Thank you.
All right, Tyler, what's one thing you
I
learned?
don't know what I learned.
All right, Tyler, what's one thing you learned?
So I learned that it is better that we don't have everything like in one function and that we split it up so that the functions aren't as long, like in the code, and it's easier to read.
All right, Charles, what's one thing you learned?
One thing I learned is how robots use line followers and other visual sensors to detect where they're going and navigate.
So, Austin, what did you learn?
Hey, Roman. You know what I learned? I learned that the line followers can be programmed to follow different colored lines, not just white and black, which honestly can be useful for so many scenarios, depending on what path you need that robot to follow.
All right, Carson, what did you learn?
I learned how important it is for your gyroscopic controls on the robot to be accurately calibrated. Because if they're not properly controlled, your robot could go off in a different direction, lose the line, and then not be able to reach the destination that you need it to go to.
All right, James, what's one thing you learned?
Well, from Tyler, I learned that when you're coding it, right, you want to set up the color sensors so that they'll detect the line but not go off of the line arbitrarily. So if it turns too far, it needs to be able to return. So in the coding, when it had to go around a crater or when it had to go around an object to get back to the line, the way he did it was definitely different than I expected, and it re-navigated itself back to the line by looking for it with the light sensors, with the color sensors, my bad.
What are you still doing here? The video's over. Go, subscribe.